Hello, everyone. Welcome to the Mining Match. Today, we will talk about geometallurgy. You know, in mining, it's wise to know how you allocate those areas of ore, because the best you mine it, you will have better results and more profit. So it's very important to know the geology and how this material will be treated in the process to extract the riches and the metals from the rock. Today, our guest speaker, Chandra Bose, will discuss the Geometallurgical Predictive Test Program for Industrial Minerals. So we welcome Chandra. How are you today?
Yeah, doing well so far. Thanks for this opportunity.
Yes, thank you. You're very welcome. So where are you connecting from India? Where in India are you now?
Presently, I'm located in a city called Chennai, which is
Chennai, okay.
located in southern part of India.
Okay. So whenever you're ready, Chandra, you can start your presentation, please.
Yeah. First of all, I would like to thank you very much for Mr. Allen for this opportunity. I'm very keen interested to share this topic with all mining professionals. I thought of this topic is very important for geologists, mining engineers, and other mining professionals. So today we are going to discuss about the importance of a geometallurgical predictive testing program. Because what is happening, most of the times the geometallurgical properties are analyzed after the mine development. Instead of it has to be done before the advanced exploration stage itself. That is not being done because of several constraints. One is like budget, another one is the lack of awareness of importance of geometallurgical testing program. So, and other reasons. So today I thought of sharing this important session with all the mining professionals across the world. So before going into this topic, let me introduce myself. I'm Chandra Bose, basically a professional geologist having almost 16 years of mining industry experience. Moreover, a member of Australian Mineral Institute since 2013. Presently, just I've joined as a consultant with one of the Indian consulting service companies. It's called Geo Exploration Consulting Services, which is located in India. They are having several exploration and mine development projects in India, Africa, and other parts of the world. So I'm very a younger guy for that organization, just only 2-3 days back joined there. So I would be looking into the international exploration and mining consultancy services projects there. Prior to that, I worked with Madan Phosphate company, which is located in Saudi Arabia. So that was a very good experience where I obtained pure industrial mining experience and worked on resource and reserve modeling, supporting with the mine planning team and the beneficiation plan team. All this, so where we implemented this geometallurgical predictive testing program extensively to improve the beneficiation and mining of productions in various stages. And my specialization is I normally involved in advanced exploration activities after the regional exploration and detail exploration and mine development program, once we have indicative exploration of geometallurgical data, then normally go for the mine development activities, giving a lot of suggestion for the mine planners and the consultant and the management of a particular company and corporate personnels, and the mining operations. Obviously, the mining operations, how they need to go for very smooth operations using the correct database and the modeling and the reports, and also involved in preparing resource reporting as per the JORC 2020 compliance. In addition to that, having extensive experience on mine to mill reconciliations, um, particularly industrial mineral in that rock phosphate deposit. In addition to that, the coal mining also. In addition to that, as well, involving in preparing standard operating procedures, providing training to the younger geologists, mining professionals, and non-mining professionals. Despite having all this experience, we could able to handle the exploration and mine development projects. So having mine management skill. So this is what about myself. Then let me go to our today topic. The today topic is a geometallurgical testing program. Okay, so somebody may think of it, why it is essential, why it is so important to discuss this topic. Actually, it is very, very essential to do this test. Normally, what is being done, once they go for the drilling test, normally they collect the RC drilling samples, which is in the powder form or semi-powder form, or they go for collecting the diamond drilling samples, which we called as a core samples. So those samples actually normally being used for analyzing the chemical properties, assay elements, and the core sample is being mainly used for geotechnical test like uniaxial compressive strength and all. But most of the companies, they failure to do the same samples using geometallurgical test analysis. The geometallurgical parameters are so essential to know the mineral processing characteristics. So it has to be done in the stage of advanced exploration stage itself, or during the mining development in well advanced stage. So these data, it's being mainly used for mine planners when they prepare for the strategic life of the mine plan and the short-term and long-term mine plan. Unless having a proper database of geometallurgical database, it's very difficult to achieve the production. We may be getting a lot of business planning aspects from the corporate office, but unless having geometallurgical properties, it's very difficult to achieve the target. So which is implicating the company business and profit losses and all. Then if you go into mining operation aspects, actually, it's really guiding the drilling and blasting pattern. So what kind of pattern they need to go for it, because what is happening? During the operations, we may have, friable material, semi-hard, hard material. But if you apply the drilling and blasting pattern uniformly, regardless of the nature of the deposit, that may, causes during the, rock process or process in the downstream. And also what I explained to you, the nature of the deposit, when we send the combination of the soft material, what we call friable material or hard material. In the plant circuit, in the milling circuit, they may face the differential grinding issues. And the fragmentation and slimes. So without knowing the geological and geometallurgical properties, when we go for the blasting, it may produce oversize or slimes, which is a lesser size, or may have the powder kind of form, which may cause us during the process. And ore blending. The ore blending will be also decided when we have all the parameters of geometrological characteristics like the slime percentage, weighted slime percentage, hardness of the material, what we called in the geometrological terminology, bond work index or crushing work index, and the recovery factor, yield and final concentrate of the particular product, what we are going to achieve in the beneficiation stage. So when we send the material from the mine side, the processing team and also the beneficiation planting operators or managers or supervisors or superintendent level, they should know what kind of material we are sending to them, what percentage of blending from a different material. So when we have this geometrological testing program inputs, that will certainly guide us, now guiding to the plant managers, the mining professionals, all these stakeholders. As I explained, the few seconds back, how it is important for these parameters for a mineral processing as well. One is the differential grinding issues, what they face when we send a different combination of the material which goes to the milling circuit. So that will, reduce the production level, and the rate of production will be down. Sometimes the breakdown, certain breakdown in the plant. So all this, and also they are unable to decide the chemical dosage factor. How much percentage chemicals supposed to be added or reduced if geometrological parameters are unknown. The same like the slime losses, if it is more powdery, then it goes into losses, even though maybe higher grade may be lost in the slimes. The flotation characteristics, it's difficult to predict which material is going to be float, which is going to be settled down. And the recovery factor, how much percentage we are going to recover, out of the designed recovery factor. Let us see, maybe our design may be 65 to 70% to be achieved, the recovery factor. But if you don't know the geometrological parameters in well advanced, it's very difficult to achieve. We may be achieving very 50% or 45% or 60. It's very difficult to achieve the nameplate targets. So if you look at all these combinations, all these, the geologist level, the mining planning engineer level, mining engineers, operations, business planning, and the corporate planning, all these people should be aware of these parameters before mine to be opened or before the material supposed to be sent for the metal process. So that is why these parameters are so essential to discuss today. Can we go to next slide? You can hear me, Mr. Allen?
Yes, I can hear you. Please go ahead.
Yeah.
You can do your presentation.
Okay.
All the way. Thank you.
Thank you. So the chain process of doing this geometrological predictive test program, normally we focus the diamond drilling samples, what we call core samples. It has to be properly logged by geologist, or demarcating the different lithological units, the physical characteristics, how this ore is looking to be whether it is soft or hard or semi-hard, and the physical hardness also can be assigned as per the standard operating procedure system. It is being adapted by the geologists that will vary deposit to deposit and minerals to minerals. For the industrial minerals and phosphate deposits, normally because of the marine organism and all, to some extent it's having a certain percentage of soft material. If it is calcareous phosphate and all, then the hardness keep on increasing. But anyway, if the physical hardness, it doesn't mean that the same hardness will be matched in the when we go for the hardness and bond work test. Maybe physically looks to be very hard, but when we crush it, it may be very soft. That is based on the mental matrix what it contains. So geological logging is supposed to be very detailed, and those details, the log sheet with the details will be shared with the metallurgical laboratories along with the core samples. The core sample is supposed to be properly marked and labeled, where the ore starts, where non-ore layers are starting. So all this information is supposed to be prepared by the geologist along with the samplers, and the samples will be shipped to the metallurgical laboratories along with the certain formats. So what exactly, actually in the industrial mineral, there are different mineral deposits like phosphate, bauxite, potash, and different things. But based on my experience, most of the times I may be discussing, about the phosphate deposit. So hardness, normally we give a lot of importance for the hardness test because, the matrix of the deposits, it's certainly varying with a different hardness from 1 to 8 or maximum 10 hardness, what we called in a bond work index. That is being measured kilowatt hours per metric ton. And the slime grade, the material which is having very soft material, what is the soft material grade? Maybe the soft may be having very higher grade. We may be losing in the tilings if we don't predict well. If we predict, we may have the additional circuit to extract only the soft material that may be recirculating to the mill with the additional equipment system and all. But when we don't predict these lines, maybe it is most of the times going into the tilings. Or, so we may be losing higher grade percentages in the slimes itself. Then flotation feed grade, that is also very important when it goes from the mill to the flotation cells. So what is the grade they are going to get? So it has to be predicted. And the recovery yield and concentrate percentage is all supposed to be predicted during the metallurgical lab test itself. So once the metallurgical results being supplied to the geologists or mining professionals or mining engineers, normally they go for the geometallurgical modeling. So normally if you look at the table, which is not very clear, but this is the confidential data we put in the corner, which is not visible now. So in the tabular format, the data might be received from the geometallurgical laboratories. So once we have all the database from the geometallurgical laboratories, we need to prepare the geometallurgical database, which can be uploaded into the softwares to make the modeling. So this is supposed to be done by the experienced modeling people. Otherwise, we may have the right database, but inexperienced people may do this. Everything might go very wrong. So once we have this, we can prepare, different the modeling layers as per the geometallurgical parameters. If you look at the screen, these data are belongs to the same area, but a different parameters. So the blue indicates the higher percentage of the hardness. The green indicates green and low, sorry, green and red indicates low percentage of the geometrological parameters. The first one, it shows the hardness. The second one is the slime grade percentage. The third one is slime weighted percentage. The fourth one is the yield. Fifth one is the recovery. And the final one is the concentrate grade. So when you have all this information in a very detailed manner, then you can integrate all these layers with the different combinations. And all the stakeholders like, processing engineers, metallurgical engineers, geologists, mining engineers, the plant operators, beneficiation personnel. So all, they, they will aware of it, what kind of material it is being, supplied to the beneficiation plant, or the mining professionals, they may know what kind of material they are going to mine down in a particular area. Yeah, go to the next slides. So once we have all this information in the modeling format, then this will be supplied to the mine planning engineers. That will be integrated with the life of the mine plan or strategic mine plan scenarios. That will clearly shows, the first year. If you look at year one, so they are going to receive the hardness 8, sorry, the 8 million tons may have 4.6 percentage of bond or index, which is indicating the hardness, and the percentage of grade quality, which might be having 19.1. So such a way we represent each year and each parameters, and we can do some correlation also. Sometimes, what we may think, if soft material may not have more hardness, or hard material may not have less percentage of P2O5. It's, it depends on the mineral matrix, what kind of, associated elements are associated with that, and the nature of those elements also playing a vital role to predicting the quality parameters. So if you look at the year 4, the 15 million tons having a 7.5 percentage of 7.5 bond or conducts, which may have the ore quality of 20.76. Here, the 20, more than 20 means maybe higher grade, but having, higher percentage of hardness also. Sometimes the higher percentage of grade may have lower percentage of hardness. So it is, unless we don't do this kind of detailed testing, it's very difficult to predict. So that is why these tests are called so essential. The same way, if you look at the run-of mine grade and the predictive concentrate grade, it doesn't, upgrade uniformly. Sometimes the lower grade upgrade into higher version, the higher grade upgrade into or downgrade into lower versions, because that depends on the location to location, the material to material, the blending scenario. So it's with the different combinations. But if you have all this information in well advanced, so everybody knew that in which year, what kind of material they are going to resolve it. So that is the essential important things, for all the engineers and managers, to run the business into very smooth level. Then if you look at all the integrated layers, the year wise, so we can do, you know, a lot of correlation with the different parameters. But if you look at the year 13, we have almost more than 8 million tons having adequate information. But if you go to year 10, it's very less, actually tonnage wise very less. Means they have not done enough testing in this area. So year 10, they do not have a sufficient database. So they may need to go for more drilling, sample analysis, predictive testing program before reaching into this area. If you look at year 15, it doesn't have any data at all. So here they may go for infill drilling to obtain the required geometallurgical database. So this graph, this chart is clearly guiding actually each and every year what kind of detailed information we are having it, we don't have it. If we are having all the information of particular year, that is fine. Where we don't have sufficient information, sufficient database, those areas need to be focused to obtain the relevant informations. Of course, that is depends on the company strategy and the business planning, budget. All this play vital role. But being as a geo professional and the mining professionals, we need to deliberately convey the message to the management how this data is so important. To have proper mine planning and the mine development progress, so that they can allocate the budget in well advance to carry out all this program. Otherwise, it's very difficult. So the next one is doing all these activities, obtaining the information, going for drilling, collecting the samples, doing the modeling, metallurgical data analysis, involving a lot of people to share, all the informations. So what kind of benefit we are going to get? Really, it is going to impact the business. So we are going to, achieve all our targets. The production will be increased. So that has to be, evaluated properly. So once we have all this information, it has to be properly circulated to all these stakeholders. What I mentioned here, geologists, mining engineers, processing engineers, metallurgists, plant operators, business planning managers, mine manager, plant manager, and corporate personnels, and internal consultant, external consultant. So all this information is supposed to be supplied to all the people, to have a very brief business planning and the mine planning to run the business as per the plan. Otherwise, sometimes what is happening, they may have all the information, but they may not circulate to all the stakeholders. So in this, suppose the processing engineer or the plant operator don't have this information, they may not know what kind of chemical dosage they need to change it. Maybe the material, the feed might be changed, but they may be using these same kind of chemical dosages. So it's very important to share all the information to the all stakeholders. And it is properly guiding the business and the operational plan to achieve annual targets, quarterly targets, monthly targets, in fact daily targets, if we have enough information. Otherwise it's always deviating from the business planning, mining planning, operation planning. Even sometimes it may affect the exploration program. So all these informations are playing a vital role to guiding the company business. Otherwise, very difficult to achieve the targets. So when we don't achieve the targets, so ultimately that is affecting the company business, profit losses, cash flow, all this. Um, and also, if we have business case studies, adapting all these informations and improving the productions, when they go for the next project, maybe each and every company may be having multiple projects of the same commodity or different mineral commodities. So they may adopt the same kind of strategy for the new mine development or new beneficiation plant setup, all this. So these are the real benefits what they are going to achieve when they are going to implement this test, geometallurgical test. I think these are the slides. It is over now. Hopefully, this will be, useful for mining professionals and geo professionals. In fact, non-mining professionals also who want to understand the geometallurgical characteristics and its importance.
All right, guys, and you out there in YouTube, thank you very much for watching, and we'll see you next time.